Hello and welcome to this section of the MATLAB tutor. In this section we're going to concentrate on learning about factorials and square roots and how to kind of manipulate all that stuff in terms of MATLAB. So the easiest one to cover first, something you probably won't use that much, but you might use it, and that's the factorial, how to take factorial of something. You might think that you would do something like 5 factorial, but it doesn't understand what that is. So what you need to do a factorial is you need to literally type in factorial and pass it as an argument, pass the number that you'd like to take the factorial of. So it literally does all the math, 5 times 4 times 3 times 2 times 1, you get 120. So basically that's how you use the factorial command. It's pretty straightforward. Now that that's out of the way, I mean, factorial is not something you'll use all that much, but occasionally when you define sequences and series in calculus, you'll be using the factorial guy. So this is where you get that information. And if you forget, you can always go here and type in factorial and hover over this guy, and it'll tell you it's factorial. You pass n, where n is a scalar, which is a number, product on all the integers to 1 to n, and it gives you all the information about what exactly it's doing. All right, let me go ahead and clear the screen. That just took a few minutes. Now what I'd like to spend a little bit more time is how to take square roots. And also I'm going to get into cubed roots and nth roots and things like that, because those are things that you'll be using pretty frequently in MATLAB, I think. There's no square root button anywhere on the screen here, so what you need to remember is to do a square root, you type in SQRT, square root. So let's do something simple. Square root of 4 is 2. So MATLAB understands the square root operator. The square root of 81 is going to give you 9. If you put something in there that's not a perfect square, like square root of 80, let's say, then it's just going to give you the decimal answer. And that's perfectly fine. Now, what if you'd like to express the square root but not do it in terms of the square root function? Just as a reminder, you can always go 81 raised to the power of 1/2, because as you all know, when you raise something to the power of 1/2, it's exactly the same thing as taking the square root. So I can come up here and say 9 to the power of 1/2 will give me 3. So there's really 2 different ways to do square roots, and it just depends on what you want to do. Using the SQRT command may be a little bit more readable. It just depends on exactly what you'd like to do. Now, if you'd like to take a root of a number that's not a square root, maybe you want to take a cubed root or a 4th root or a 5th root, there is a function for that. And to demonstrate, I want to show you how you might use the help system if you happen to forget the syntax. So you just type this in, type in nth root. Okay, there is a function called nth root of real numbers. So it says you pass it 2 values. The first one is a number. The second one is whatever root you're trying to take, and it should return the nth root. So let's type in nth root. All right, and let's type in something we know. I happen to know that the cubed root of 8 is something that we can easily find. So the first number you pass it is the number you want to take the root of. The second number you pass it is what root it is. So in this case, it's a 3rd root or a cubed root. So we're going to go ahead and hit enter, and the answer is 2. The reason it's 2 is because 2 times 2 times 2 gives you 8. So let me recall the last command. Another nice cubed root that I just happen to remember is the cubed root of 27, which is 3, because 3 times 3 times 3 is 27. So that's kind of nifty. Now, also, those of you this high up in math also know that you can do things like taking 27 raised to the power of 1/3. Much like 1/2 gave us a square root before, raising something to the 1/3 power will give you a cubed root. It's mathematically the same thing. Okay, so if you wanted to do something like take the cube root of 8, you could do it that way. So you could definitely handle all of this stuff by just raising things to fractional powers. The only thing is it kind of sacrifices a little bit of readability, but you can totally do it. If you want to use the square root command, that's fine. If you want to use the nth root command, that's totally fine too. Those are all available to you. Now I'd like to clear the screen really quickly and turn your attention to using the square roots functions when you have basically a symbolic system going on here, when you want to treat it perfectly. A lot of times in algebra you have the square root of 40 or something like that, and you do the factor tree and you like to figure out what that is equal to. So obviously you can go square root of 40, right, and you'll get a number. I know the answer is 6.3246, but if you wrap that in a symbol, square root of 40. Right, so now it's doing square root of 40, but the answer basically is going into the symbol operator, so it's trying to keep everything exact. And when you do that, the symbolic math toolbox kicks in because we did this symbol operator here, and the answer we get is not a decimal. We get something more perfect than that, 2 times 10 to the 1/2. And if it's hard for you to read that, I mean, it's fine for me, but if it's hard for you to read that, you can type in pretty answer, and you'll see 2 times 10 to the 1/2. Now you should know that anything to the 1/2 is just a square root. So really what we have is 2 times the square root of 10. 2 times the square root of 10. And we all learn in algebra how to factor 40 and get all of the common things and do all this by hand, but you can use MATLAB to keep everything perfect as well. So, you know, if you wanted to do something, you know, taking the square root of 40 is not a big deal, but what if you wanted to take the square root, you know, the perfect square root of, you know, something large like this? Let's see what MATLAB does. Okay, very exact answer, right? It keeps everything as exact as it possibly can. Notice that this is a huge numerator divided by a huge denominator. If we want to convert it to a decimal, then this is going to be the square root of that large number. Let me go ahead and clear the screen to declutter our screen. What if we wanted to do, as another test, symbolic representation of the square root of, let's say, 1050, something large. This is something that would take you a little while by hand to actually factor it all out, collect all the terms, and figure out what it all is. MATLAB quickly tells you it's 5 times 42 to the power of 1/2, which, if you want to visualize that a little bit better, that's 5 times 42 to the power of 1/2, so 5 times the square root of 42 is going to be that answer. And if you require that in decimal form, you can always just type double answer. It basically converts whatever you want to a decimal. So the answer is 32.4037. All right, so that about covers everything I'd like to cover in this section. We learned how to take the factorial of a number. We've learned how to take the square root. We've learned how to take the nth root. And we've learned how to use the symbolic math toolbox to manipulate square roots to simplify them into exact form, which is something that's pretty common, actually, that you might need to do. And then if we need to, we can take these answers and convert them back to decimal as well. So the nice thing about MATLAB is you have the flexibility of both. You can work in decimals. That's sort of the default mode, and that's fine. If you want to deal in pure math terms, you have that option as well. It just takes a little bit of time to understand how to talk to MATLAB to get it to do what you'd like it to do.